All right. So now we'll continue with today's lecture notes. And we're just going to continue right on, and we're going to talk about a weak bases. Well, we'll start working on our way through. We're also going to try to get to buffers today. So we've done a problem for a weak acid in water. So now let's talk about a weak base in water. And you can start us off. So in this problem, we're given a molarity, so you didn't have to calculate that. And now you can help me fill out the table so we know what to do here. Okay, let's just do 10 more seconds. Very good. So you're going to be losing some of the amount of the weak base you have in is going to ionize, and so then you'll be forming the conjugate acid plus X, and you're going to be forming hydroxide ions plus X. And so the one with the minus sign is important, and sometimes there will be 2's involved, and that depends on the stoichiometry of the reaction. All right, so we can use that information now and go on and look at, actually, you could leave that clicker question up for a minute. And we're going to talk about the KB. So the KB is going to be equal to our products, NH4 plus, and our hydroxide ion concentration over NH3. And so now I can fill in the values that you told me. So we have, on the top, we're going to have x squared. On the bottom, we're going to have 0.15 minus x. And now we can make an approximation here that x is going to be small compared to 0.15. And so we can say that's just going to be equal to x squared over 0.15. And the KB value that was given was 1.8 times 10, let's see, we have it here, to the minus 5. So now we can solve for x using this approximation. And using this approximation, x comes out to be 0.00164. And we can look at whether that approximation was OK. So is this number less than 5% of 0.15? So we can say 0.00164 over 0.15 times 100. And that comes out to be 1.1%. So that's OK. That's less than 5%. So that's good. We don't have to use the quadratic equation here. So now we want to calculate the pH. So can I just plug that number for x into my pH equation? What is x? What is x equal to here? It's equal to 2 different things. What's one of them? Hydroxide ion concentration. So what we can do is calculate a POH. So POH is minus log of the hydroxide ion concentration, or minus log of 0.001647. And we really only have 2 significant figures here. And that is going to come out to 2.79. And so we would have 2 significant figures after the decimal point because this number had 2 significant figures in it. But I'm not done. I've calculated POH, and the problem wanted pH. So how do I go from POH to pH? 14 minus. Yep. So 14.00 at room temperature minus 2.79 is going to be equal to 11.21.